Now that we've learned how the periodic table is put together, and we've also learned how many electrons are in atoms of a particular element, we're going to put the two together, and we're going to look and see how electronic structure is, what electronic structure is and how you see it in the periodic table. Electron structure is very organized. Although the electrons have a lot of freedom in moving around, they can't be just anywhere. There are only certain places they can be and certain energies. The places are organized almost like an address, where there's almost like a street and a number and a house and then a little floor level, etc. But we're going to look at this very, very simply, and the only thing we're going to look at is a principal energy level. Within a principal energy level, there's a sublevel. Within the sublevel, there's orbitals. Within orbitals, there's spin, but we're going to keep it really simple. So the only elements that we're going to look at the electron structure of are the representative elements, and really only those within the first 20 elements, because once you get past that, it gets a little more complicated, and we're going to try and keep this as simple as possible. With the principal energy level, we give it a symbol N, and as that N number increases, the electron is farther from the nucleus and the energy of the electron is higher, kind of like a ball at the top of the stairs is farther away from the bottom, and so its energy is higher. And a ball at the bottom of the stairs on the first step is closer to the floor level, and so its energy is lower. And that's very much what like this is. The numbers start with 1 and go out to infinity, but we're going to only look at the lowest numbers. N equal 1 will hold a maximum of 2 electrons. It can hold 0, 1, or 2. N equal 2 holds a maximum of 8. So it can hold anywhere from 0 up to 8. N equals 3 can hold more than 8, but we're keeping it simple, so we're not going to look at any atoms that have any more than 8 in N equal 3. And so it can N equal 3 can hold from 0, and for the elements we're looking at, up to 8. N equal 4 can hold even more than N equal 3, but we're only going to look at atoms which hold up to 2. Okay, we're going to look at the first column, and in the first column we're only going to look at the first 4 elements. The atoms below you're going to see would be very similar if we looked at this in any more depth. There's some differences, but there are a lot of similarity there. Let's first, though, just look at hydrogen, lithium, sodium, and potassium. Hydrogen, which has an atomic number of 1, meaning 1 proton, has 1 electron in the atom when it's neutral. Where is that electron? It's in N equal 1. Electrons always go to the lowest possible energy place, and the lower the N number, the lower the energy. Lithium has 3 protons, and so 3 electrons in a neutral atom. Well, where are they? Well, 2 of them are in an N equal 1, and 1 is in N equal 2. Sodium has 11 electrons. Where are they located? 2 in N equal 1, 8 in N equal 2, 1 in N equal 3. Potassium has 19 electrons. 2 are in N equal 1, 8 in N equal 2, 8 in N equal 3, and in N equal 4, there's 1 electron. What do you see that's the same with all of those? They all have 1 electron. And what we're going to discuss later, they also all have they have 1 electron in the highest N number. Later on, we're going to call these valence electrons. What else to notice? Well, higher N number means higher energy. So the electron in hydrogen has the lowest energy electron, and potassium has the highest energy electron when we're just comparing that column. Because hydrogen has only one electron close to the nucleus, and the others have more farther away, and remember the nucleus itself has almost no volume, it's all electrons that determine the volume of an atom. Hydrogen is a teeny tiny atom, and potassium, of the 4 on the periodic table that I've shown you, it has the largest diameter atom. Well, let's look at the second column. The first column is called the alkali metals. The second column is called the alkaline earth metals. If I look at beryllium, then I see that it has 4 electrons. Where are they? 2 in n equal 1 and 2 in n equal 2. Magnesium has 12 electrons. Where are they? 2 in n equal 1, 8 in n equal 2, and 2 in n equal 3. Calcium has 20 electrons, and where are they? 2 in n equal 1, 8 in n equal 2, 8 in n equal 3, and 2 in n equal 4. Notice all of these have the highest n having 2 electrons. For the third and fourth column representative elements, for boron, there's 5 electrons total. 2 are in n equal 1 and 3 in n equal 2. Carbon, 6 electrons total. 2 in n equal 1, 4 in n equal 2. Aluminum has, it's got 13 electrons. Where are they? 2 in n equal 1, 8 in n equal 2, and 3 in n equal 3. Silicon looks just like aluminum, it just has 1 more electron in n equal 3. Notice carbon looks just like boron, but has 1 more electron in the n equal 2. That helps you recognize this pattern to see this, so that it's easier for you to come up with an electron structure. In the fifth and sixth columns of the representative elements, what do you have? Nitrogen, 7 electrons, 2 in n equal 1, 5 in n equal 2. Oxygen, 8 electrons, 2 in n equal 1, 6 in n equal 2. Phosphorus has 15 electrons, 2 in n equal 1, 8 in n equal 2, and 5 in n equal 3. Sulfur looks just like phosphorus with 1 more electron. And where does it go in that highest energy level of n equal 3? And then last of all, what do we have? We have the 7th and 8th column. All of these are called the noble gases, and these are called the halogens. Let's look at the noble gases first. Helium has only 2 electrons, and they're in n equal 1. Neon has 2 electrons in n equal 1 and 8 in n equal 2. Argon has 2 electrons in n equal 1, 8 in n equal 2, and 8 in n equal 3. Notice that neon and argon all have 8 electrons in that highest energy level. Helium only has 2 though. Remember, these are the inert gases, and we'll go back to this electron configuration in order to talk about stability. Things that are real stable are inert. All right, let's look at fluorine and chlorine. Both have 2 electrons in n equal 1. Fluorine has only 9 electrons total, so there's only 7 electrons in n equal 2. Chlorine has a total of 17 electrons, so there's 8 in n equal 2 and 7 in n equal 3. So now what I want you to do, with only looking at a periodic table, not looking back at the former slides, figure out where are the electrons in a neutral atom of the element with 14 protons. Well, this is silicon, and silicon has 2 electrons in n equal 1, 8 electrons in n equal 2, and 4 electrons in n equal 3. Notice 2 plus 8 plus 4 add up to 14, because the number of electrons must be equal to the number of protons in a neutral atom. What element has 6 electrons in n equal 2? Well, we're going to go to the second row of the periodic table, because n equal 2 means there's no electrons above it. So that must be the highest energy electrons. N equal 2 means it's in highest energy electrons means it's in the second row. So we go and we find out, count 6 columns over in the representative elements, and we find that that is oxygen. Another way that you can figure this out is to say, well, n equal 1 must have 2 electrons, n equal 2 has 6 electrons, and there can't be an n equal 3 because n equal 2 has to be full before n equal 3 gets any electrons. So the total number of electrons in the atom is 8. That is oxygen. There's more than one way to do a lot of problems. For the second exam, you will need to know what symbol belongs to which element for the first 20 elements. For example, you need to know that Ca stands for calcium and C stands for carbon. And there's, of course, more elements than just those two, but those are two that are easily confused. So I wouldn't sit down and memorize the symbols right away. If you're doing your homework, you're going to know the symbols by the time you get to the exam.